So let's say you are seated peacefully in the exam, minding your own business, and they decide to ask you a situation like this. It says a 6 kg block held at rest on a rough horizontal table is connected to another block of mass 3 kg by a light, inextensible string passing over a frictionless pulley. The 3 kg block hangs vertically, as shown in the diagram below. When the 6 kg block is released, it accelerates to the right and experiences a kinetic frictional force of 24 newtons. Ignore the effects of air friction. So the first question we are not going to entertain because you can take care of it. The next one says, draw a labeled free body diagram showing all the forces acting on the 6 kg block. And this is what you must pay attention to, the mark allocation. It never lies. It tells you how many forces must be there. So 4 marks, 4 forces must be there. Even though they didn't ask you to draw the free body diagram for the 3 kg block, you still draw it as well, but on your rough work section. So let's go to the whiteboard for that. So we know that the object is represented as a dot, the 6 kg block, and the forces as arrows pointing away from the dot. Now, because this block is on a horizontal surface, there's going to be an upward normal force, which is perpendicular to the surface. Do you see that? And in this case, because there is no other force acting at an angle, the normal force will be equal to the gravitational force. They're equal in magnitude, but opposite in direction. And then we say the 3 kg block is pulling the 6 kg block to the right. So we have tension force going that way. And then we know that the frictional force, kinetic frictional force to be specific, it opposes the motion of a moving object. So it's going to go to the left. This is your free body diagram. And the tension has to be greater than the kinetic frictional force. Why? Because the block is accelerating to the right. It means the tension is greater than the frictional force. Right. Now let's draw the free body diagram for the 3 kg block as well. So for this one, we only have 2 forces that are acting. We have the tension force, which is going upwards because the 6 kg block is pulling it upwards. And then we also have the gravitational force, which is going downwards. So it has to be greater than the tension force. Why? Because the 3 kg block is accelerating downwards. So this is what we have. Awesome. Now let's look at the next question. This one says, calculate the magnitude of the acceleration of the 3 kg block. Do you see that? So in order for us to calculate the magnitude of the acceleration, we have to use simultaneous equations. Why do we use simultaneous equations? It's because these 2 blocks are connected by a string, a rope, or a cable. So every time you have this situation, in order for you to calculate the tension and the acceleration, you must use simultaneous equations. So what is the concept? We apply Newton's second law to each of these two blocks separately. So let's go and do exactly that. So we start with the 6 kg block. We tell them. So here we focus on the 6 kg block. Then we tell them that the net force acting on the 6 kg block, according to Newton's second law, it is equal to MA. But what is this sum of forces? Well, we only have two forces that are horizontal. So it's the frictional force and the tension force. And we need to decide on direction. So let's say anything that goes to the right is positive, and anything that goes downwards is positive as well, because we are choosing the direction of motion as positive, right? So this means the tension force will be positive, but the kinetic frictional force will be negative. And this is equal to MA. The magnitude of the kinetic frictional force for the 6 kg block is given to us as 24 newtons in the statement. And then we say the mass is just 6, then we times this by A. So if we make tension the subject of the formula, we just take this 24 to the right, it becomes positive. And then we call this our first equation. Then we shift our focus. We look at the 3 kg block. So once again, we tell them that the net force acting on this block is equal to MA. We only have two forces here which are vertical. So we say it's the tension force which is going up and the gravitational force which is going down. And remember we said downwards is chosen as positive. So this is what we have. So we know that if we want to calculate the gravitational force, we just take the mass of an object and multiply it by the acceleration due to gravity. And then we say this is equal to 3A. And then we take this tension force to the right so that it becomes positive. And then we take this 3A to the left so it becomes negative. The aim is to solve for the tension. You could have decided to take this one to the right, and then you divide both sides by -1. It's up to you. But I'm just going to take the tension force to the right. So this means 3A will be negative, and then 3 times 9.8 will simply be 29.4. And then we call this one the second equation. Then here we realize these two equations are equal because they are both equal to T. So because they are equal, we equate them. So we say 6A plus 24 equals -3A plus 29.4. Then we take this 3A to the left. We take this 24 to the right. So 6A plus 3A, we simply get 9A. And then if you say 29.4 minus 24, you simply get 5.4. Then from this point, you divide both sides by 9. So you find that the acceleration will be 0.6 meters per second squared. They only asked for the magnitude of the acceleration. If they said the direction, then you'll say downwards because the 3 kg block is moving downwards. So this one, they can ask it in one of three ways. They can say, calculate the magnitude of the acceleration of the 3 kg block as they did. Or they can say of the 6 kg block, or they can say of the system of these two blocks. So the approach is exactly the same. So this is the end of this question. But let's say they asked you to calculate the magnitude of the tension. In order for you to find the tension, you start by calculating acceleration. And then you can substitute your acceleration either into equation 1 or equation 2 to calculate the tension. So let's say maybe you want to substitute it into equation 1. So you'll say the acceleration is 0.6, and then you say plus 24. So 6 into 0.6 plus 24 will just give us 27.6 newtons. You'll still get the same answer, even if you used the second equation. I'm just preparing you just in case they ask you for the tension. Right. Now let's look at the last question. The last question says, explain the following statement. The acceleration of an object is 0.6 meters per second squared. In other words, what is the meaning of 0.6 meters per second squared? So remember, when you define acceleration, you say it's the rate of change in velocity. So this simply means the velocity of an object changes by 0.6 meters per second every second. That's the meaning of 0.6 meters per second squared. So the velocity changes by 0.6 meters per second or every second. And then your happiness is complete.